ready for another day? Okay. So I was going to do another. You guys don't like the demos, right? They're kind of boring, huh? You guys want to skip the demo today? No? Okay. Well, then we'll have to do the demo, I guess. We're going to look at. We haven't really, we've done some demos, we've talked a little bit about science, and it's just mostly to give you just kind of a flavor of it. You've noticed that the ChemAcad mostly has been some math and some study skills, kind of just give us the things we need in order to do the Chemistry Academy. We'll look at chemistry is the study of matter, and so what do you guys think about matter? What's matter to you? What do you guys think about matter? It's everything? Is matter everything? Does anybody disagree with that? Anybody want to? No? I have a couple people. Either one. What do you think? Juan, I guess.
Antimatter.
Well, let's not go into antimatter. There is antimatter, but let's look at matter first before we talk about antimatter. Go ahead.
There's matter and there's energy.
That was more about what I was getting to. So matter is anything that has mass and takes up space. So when we weighed things, we were determining mass and things that take up space. And so one thing that you can think of that is not matter, because you're surrounded by matter. Tables matter, you're matter, you breathe matter, you swim in matter. But light is an example of energy. Oh, there we go. Let's switch. There we go. So what scientists do is they actually look at how light, chemists particularly, they look at how light interacts with matter. And that can be really interesting. If you do chemistry on a higher level, you look at light, light's energy. Light travels as a wave. This is kind of a neat little, can you guys see that okay? Or should we knock one of the more light down? Let's knock one, is it okay if it's a little darker in here? Is it okay? So okay, there we go. So this is showing light traveling as a plane wave. Light typically, more oftenly, travels as what they call circularly polarized. It travels like a corkscrew. It has no mass, but it interacts, it's energy. It can interact with matter. There's a couple examples on here of when light interacts with some matter. This is showing light interacting with matter. What's happening to it? What can you guys see happening? What does that look like?
Losing something.
Do you see how it's taller when it first comes out and then it gets smaller? So this is showing light being absorbed. So light can be absorbed by matter. So the matter can absorb energy from light. That's an important property of light. Let's see. Light can change, that's showing the corkscrew light and also in an absorbing medium. Let's see, there was another one here we had. In a refracting medium, this is kind of interesting too. If you look here, you'll notice the light waves are very compressed. Over here on this side, they're more, the corkscrew's more or the spring, if you will, is more stretched out. In the matter, which is represented by the little box, it's more compressed. And then when it comes out again, it stretches out again. And so those are a couple of the properties of matter and light interacting. Let me go back to the light for a second. So there's a large amount of light that's striking the Earth all the time from the sun. The sun, all kinds of light comes from the sun. We only see a very small amount of it. The light that we see, visible light, the Roy G. Biv, right? Your rainbow of colors, red, orange, yellow, green, blue, violet. It turns out that there's a tremendous, that's just a small, the visible range. There's ultraviolet, there's a whole range of light, X-rays and gamma rays on one side of the spectrum, and these are invisible. And there's another set of invisible infrared and microwaves, and then finally radio waves. Radio waves are light waves, but we just can't see them. So there's a whole bunch of invisible light waves, and they interact with matter. The demo I wanted to show today is one idea of when light comes in. I'll show it like this, as traveling as a wave, kind of like you saw on the screen. It interacts with an atom. This is kind of one of the most fundamental things that you'll see that allow researchers to understand about chemistry. That when light strikes an atom, it will excite an electron up to a higher state, and the electron will come back down and then release light again. And then sometimes the light coming out is changed. And so the scientists will look at, well, how did the light change? Sometimes you might shine in a blue light, and then it might excite an electron up, and then it give back a red light or something else. And so we're going to show this principle, ultraviolet light. I'll turn off the light again. So you guys, how many people have you seen, before I turn off the light, how many people have you seen a black light? So only half of you have seen a black light? Okay, so the black light produces ultraviolet. Plugged in. Uh-oh.
It takes a while before it goes on.
Which ones do I need to have down? It's got like these switches. There we go. Is it? Ready to turn it off? Uh-oh. Maybe I want the. Oh.
There we go.
Oh, it turned red.
Shine down here because you can see.
Uh-oh. And the switch is finally given out. Okay, there we go. We can get both of them. Okay, good. All right, so the black light, you guys have probably seen these before. They look purple, right? The purple is just a safety coating. Actually, the ultraviolet light that comes out is invisible. And so the safety coating is there as a protection device, because otherwise the light bulb would be on and you wouldn't know it. It would look like a light bulb that's off, and you put your eye up to it and go, is that light bulb on? Is that light bulb on? And then you're blasting your eye with ultraviolet, which is really, it could damage your eye. So this is just a safety coating. But the light truly is invisible. So the first part of the demo to show, this is, you guys can do this at home too. You can take one of your highlighting markers and take a pair of pliers, break it apart, and put the cartridge into water. This is the fluorescent medium in your marker. And so what's happening, just a real simple demo, the ultraviolet light is striking the molecule and it's exciting the electrons. And then when the electrons relax again, it's giving off visible light. And so that's what you're seeing, this visible light. And depending upon how the electrons jump up, you can get different wavelengths of light. This one's kind of a yellowish green. If you have a different molecule and excite it differently, you could get an orange or a red fluorescence. This is kind of neat. You guys had your Christmas parties, and maybe your uncle had a gin. Does anybody? I don't know, but maybe gin and tonic. So tonic water. Actually, let's try Anne's. She brought in the larger one. Tonic water has this compound called quinine, and so you guys can see it's invisible here. It just looks like water. I shine it up to the black light and it's fluorescing, and you can see, so this is a different wavelength of light that's produced. The ultraviolet's exciting the molecule in there, and the electrons are jumping up, and then when they relax, they're releasing the blue light. And so does anybody know about quinine? So I thought it would just be fun I looked it up because it's kind of a fun thing. There's a lot of history between quinine. You know, in the computer age, we have all this information. You guys can go on Wikipedia. You know, being a student, anytime the teacher says something, what was that? If you could just write it down in your notebook, you can go back later and look it up on Wikipedia. And there's a whole bunch of information. And then in each one of these is a little thing I can click on. I can read about quinine. They're showing me the molecule. You don't have to worry about this. This diagram, you know, we'll learn about this later in the class. You don't have to worry about this, but the little black balls are the carbon, the red balls the oxygen, the white balls are the hydrogen, the blue ones the nitrogen. And it turns out that the arrangement of these atoms in space allows it to absorb the ultraviolet light. Having the carbon atoms in this double ring and the way that they share electrons allows it to absorb light differently. Not all chemicals will fluoresce, only if they have the correct structure. And then quinine has a really interesting history. I went and looked this up. Quinine, well, the British imperialists, they go to these tropical regions to get their industry going, and they would meet people of those regions, and we'd have an exchange of diseases. And so one thing they encountered was malaria. And it turns out that the quinine is treatment for malaria. And does anybody know about malaria? So you can read, malaria is this disease that's created by a mosquito, and then there's a plasmodium. So you can read about all this stuff. It's a protozoan. There's a little microorganism that lives inside the gut of the mosquito. And when he bites you, this little microorganism goes into your bloodstream, and then it essentially sets up shop in your liver, and it creates little children and eats your liver. And so to prevent that, they'd send the British soldiers out there, and they would have them drink this compound quinine, and it tasted really awful bitter. And so what they would do is mix it with a little gin, and then it seemed to taste better. And so that was kind of like standard issue for the military back then. It's another neat thing about, you know, the chemistry is all of this stuff has a history as well. All these subjects kind of tie in together. And when as you guys go through college, you want to be astute. You can, you know, read up on all this stuff. Read up on it. There's some dye you use in the lab. You can read up on the dye, and a lot of these things have really interesting histories. And so I hope that was an interesting demo for you guys. It's kind of a simple one, but you can do these at home. One of the chemistry guys, I think he was trying to boil this down and make bubbles out of it. It was another like fluorescent bubbles, but again, we have our demo workshop that we have to visit, and we're creating more demos all the time.